So this video is just going to be looking at the continuation of the previous proof on circle theorems number 1. So the proposal was that all angles that have their vertex on the circumference and are subtended by the same segment are equal. So what that means is if you have a diagram that looks like this, okay, it looks very similar to theorem 1 in the sense that we know that this angle right here, sorry, if this is x, this is going to be 2x. We know that, right, from the first video. So this proof proposes that if we join another point right here, this angle will be the same as this angle. So this will also be x. This is what this proof proposes. So I'm just going to quickly label these points to hopefully prove what's going on. So I'm going to label this again as the origin, this as R, this as S, this as P, and this as Q. What we have here is, what we're going to do is join P and Q and O to the origin. So P, this joins up to the origin, and this joins up to the origin right there. Now, we're going to let the angle PSQ, we're going to let that equal x. So PSQ, we're going to say this is x. So therefore, we've proved from the first theorem that POQ will equal 2x. In other words, this is just twice the angle of what this one is. Okay, and since the angle PRQ is equal to x as well, okay, we know that the angle, therefore, the angle PSQ equals the angle PRQ. Okay, and that solves that particular proof. It's just quite a straightforward, simple one. So let's take this onto another example, the special example of all angles subtended by the diameter on the circumference are right angles. So let's just draw that example out. So I'm just going to draw again the origin. We're going to have one point right there, another point right there. And I'm going to call this point, let's just say P, and I'm going to call this point Q. So it's saying that whenever you draw a point from here, you will always get a right angle. That obviously doesn't look like a right angle, but that's the theory behind it. Let me just quickly draw this. There we go. And so if you draw another one right there as well, that angle will also be a right angle. So what we can say here is, since the angle POQ is equal to 180, okay, because it's a straight line, we can again use the fact that we're going to let R equal the angle subtended at the diameter. Okay. Therefore, the angle PRQ equals 90 degrees. And hopefully you can guess why it equals 90 degrees is because since the angle at the center is twice angle PRQ. And since PRQ is 90 degrees, POQ will be 180. So very short proof, but very nice indeed in proving this. Let me just finish it off with is AQ